So hello friends, now we are starting example number 13 from question number 2, miscellaneous exercise 5. Observe the given condition in this example. It is OA bar is denoted by what? A bar. OB bar is denoted by B bar, and we have to show that the vector along the angle bisector of angle AOB is given by D bar is equal to lambda A bar upon magnitude of A bar plus B bar upon magnitude of B bar. So here this OA bar and OB bar are nothing but sides of which angle? AOB. So here let us consider one angle AOB. So let this will be say OA and this will be OB. So this will be angle what? AOB. According to given condition, OA bar means what? A bar and OB bar is B bar. And our example is related with angle bisector. So let us draw the angle bisector of this angle and take any point P on this angle bisector. Let us suppose that here P is one point on this angle bisector of angle AOB. So whatever may be the given conditions are there, first write down this given condition. So in angle AOB, what is given condition? OA bar is equals to A bar and OB bar is equals to B bar. This is the given condition, that one angle is given to us and its one side OA bar is denoted by what? A bar, and OB bar is denoted by what? B bar. Now we have taken one point P on this angle bisector. So let P is a point on angle bisector of angle AOB. Now once we have taken point P, so from this point P, draw one segment or draw one line which is parallel to what? OB. So let us suppose that here PM is parallel to what? OB. So draw PM parallel to what? OB, as shown in the figure. So what is our construction here? PM is parallel to what? OB. And we know that if two lines are parallel to each other, at that time pair of alternate angles are what? Equal. So since these two lines are parallel, so that's why we can say that these two angles are equal, because these are the pair of alternate angle. Means which two angles are equal? Angle BOP is equal to OPM. So therefore we can say that angle BOP is equals to angle OPM. So these two angles are equal since these are the alternate angles. Let us denote this result say by equation number first. Now even here OP is nothing but what? Bisector of this angle. Since OP is the bisector, so it divide this angle AOB into equal part. Means these two angles are also what? Equal. Means here also we can say that angle BOP is equals to angle, which angle? POM is equals to angle POM. Let us denote this result by equation number 2. And what is the reason? OP is bisector of which angle? Angle AOB. Since OP is the bisector of this angle, so that's why we can say that these two angles are equal. Now consider here triangle PMO. So in triangle PMO, let us see what result we are getting here. In triangle PMO, see here, in this case, these left hand sides are what? Equal. Since left hand sides are equal, that's why we can say that these right hand sides are also what? Equal. Means which two angles are equal? Angle OPM is equals to angle POM. This result we are getting from which two equation? From equation first and second. So we can say that these two angles are equal since these left hand sides are equal. So means we can say that these right hand sides are also equal. Now what result we have got here? In this triangle, two angles are equal. This OPM and POM are two angles of this triangle. And we know that if two angles of a triangle are equal, then side opposite to them are also what? Equal. So which are the side opposite to this angle? PM, and side opposite to this angle is OM. So we can say that therefore, or this implies that PM is equals to what? OM. PM is equal to OM, or we can say that MP is equal to OM. MP is equals to OM. Give here region side opposite to equal angle. Opposite to equal angles. So well, we have shown that the length of these two sides are equal. Let us denote it say by equation number 3. Now we are supposing that A cap is a unit vector along OA bar and B cap is a unit vector along OB bar. So let A cap be the unit vector. A cap and B cap be the unit vectors along A bar and B bar. A bar means what? OA bar, and B bar means what? OB bar. Means in short, A cap is unit vector along OA bar and B cap is unit vector along B bar. B bar means what? OB bar. And once A bar is unit vector, means its value will be equals to A bar divided by its magnitude, and B cap is a unit vector along what? B bar. So therefore B cap will be equals to B bar divided by magnitude of B bar. Already we know that unit vector can be found out applying this formula. So now here we can observe that therefore now we are trying to find out value of OM bar here. OM bar is equals to, now this OM bar and A bar are collinear vector. Since OM bar and A bar are collinear vector, and A cap is also what? Unit vector along OM bar. A cap is unit vector along A bar, means we can say that A cap is a unit vector along OM bar. Means OM bar and A cap are collinear vector, and since these two vectors are collinear, that's why we can say that OM bar is expressed as scalar multiple of A cap. In the same way, second vector is what? Here MP bar, this MP bar is parallel to, now observe here, very important result is there, this MP bar is parallel to what? OB bar. And which is the vector along OB bar? Vector along OB bar is what? B bar. And which is the unit vector along B bar? Unit vector along B bar is what? B cap. We have denoted unit vector along this OB bar is B cap. Now here MP bar and B cap are parallel to each other. Since these two vectors are parallel, again which condition is satisfying? That one vector is expressed as scalar multiple of another vector. Now here we have got the value of OM bar also and MP bar also, and these are nothing but two sides. OM bar and MP bar are two sides of this triangle. Using this we are trying to find out OP bar. What is the OP bar? OP bar is the vector along angle bisector, and question is also to find out what? Vector along what? Angle bisector. And here which is the vector along angle bisector? OP bar. So now we are trying to find out OP bar applying triangle law of vector addition. So by triangle law of vector addition, see what result we will get. Observe the figure very carefully. OP bar is equal to OM bar plus MP bar. This OP bar will be equals to OM bar plus MP bar. This result we have got applying triangle law of vector addition. Now we are replacing OM bar by lambda A bar plus MP bar by what? Lambda A cap and MP bar by lambda B cap. So which is equals to, keep this lambda as it is, but A cap can be replaced by what? A bar upon magnitude of A bar plus lambda, keep it as it is, and B cap can be replaced by what? B bar upon magnitude of B bar. So if we are taking lambda common from both the term, what we'll get here? A bar upon magnitude of A bar plus B bar upon magnitude of B bar. On this side OP bar, keep it as it is. Just simply I am denoting OP bar by what? D bar, because here this vector is denoted by what? D bar. Means vector along what? Angle bisector is denoted by D bar. So in this way we have got our required result. Here write down where OP bar is equals to what? D bar. This OP bar simply we are denoting by D bar. Here what is OP bar? OP bar is nothing but vector along what? Angle bisector. And question is also to find out vector along angle bisector, and we have to prove that its value is defined as what? D bar is equal to lambda into A bar upon magnitude of A bar plus B bar upon magnitude of B bar. And here we have got the same result. So in this way we have got a vector along the angle bisector of angle AOB. Now observe the given condition in this example. So in example number 14, the position vector of 3 vertices of the parallelogram is given to us. This is the position vector of first vertex, this is the position vector of second, this is the position vector of third vertex. Using this, question is to find out position vector of fourth vertex. So I have denoted here first vector by A bar, second vector by B bar, third vector by what? C bar, and D bar, and D bar be the position vector of 4 vertices of this parallelogram ABCD. So one parallelogram is given to us. I have denoted this parallelogram by what? ABCD, and position vector of 3 vertices are given to us. So we are supposing that A bar is position vector of vertex A, B bar is position vector of vertex B, C bar is position vector of vertex C, and D bar is the position vector of vertex D. But here position vector of fourth vertex is not given, and question is to find out position vector of this fourth vertex. Means question is to find out value of what? D bar. Now we will use the condition which are satisfying by the parallelogram. So because the quadrilateral is what? Parallelogram. We know that in a parallelogram opposite sides are parallel to each other. Since opposite sides are parallel, means in terms of vector we can say that directions are same. Even we know that opposite sides of parallelogram are equal. Equal means this length of AB is equal to DC, means in terms of vector we can say that magnitudes are equal. Means magnitude are equal, directions are same. That's why we can say that AB bar is equal to, means this vector AB bar is equal to what? DC bar. Give the reason here: opposite sides of parallelogram. These are opposite sides of parallelogram. That's why we can say that these vector quantities are equal. Hope you have got it. These are what? Vector quantity. To say that two vectors are equal, magnitude should be equal. Why we are saying that magnitude of AB bar and DC bar are equal? Because these are opposite sides of parallelogram, and we know that opposite sides of parallelogram are equal. And why we are saying that these again, which condition should be satisfied if two vectors are equal? Direction should be same. Why directions are same? Because these opposite sides of parallelogram are parallel. Parallel means directions are what? Same. Okay, that's why we are saying that these vector quantities are equal. Now AB bar in terms of position vector can be written as what? B bar minus A bar, and DC bar can be written as what? C bar minus D bar. Now question is to find out what? D bar. D bar is the position vector of fourth vertex. So let us simplify this expression. Minus D bar on this side will become plus D bar. Minus A bar on this side will become plus A bar, plus C bar, keep it as it is, and this plus B bar on this side will become what? Minus B bar. Now remaining part is just to substitute the values. So therefore D bar is equal to, I am replacing A bar by its value. What is the value of A bar? I cap plus J cap plus K cap plus value of C bar. C bar is equal to 7 I cap plus 9 J cap plus 11 K cap minus which vector? D bar. What is the value of B bar here? I cap plus 3J cap plus 5K cap. So which is equal to, first I am collecting the terms of what? I cap here. So let us collect the terms of I cap. 3 terms of I cap is there. Here its coefficient is 1, here its coefficient is 7, and here its coefficient is minus 1. Means simply we have taken I cap common from these 3 terms. Now we are collecting the terms of J cap. So collect the terms of J cap. Here coefficient of J cap is 1, here 9 and minus 3. Isn't it? Lastly, let us collect the terms of K cap. Here coefficient of K cap is 1, here coefficient is 11, and here coefficient is minus 5. Let us see what we'll get. Here plus 1 minus 1 will get cancelled. 7 into I cap is 7 I cap. Then here 1 plus 9 is 10, and 10 minus 3 is 7. 7 into J cap is 7 J cap. And lastly, here 1 plus 11 is 12, 12 minus 5 is 7. So 7 K cap is the value of what? D bar. And what is D bar? It is position vector of fourth vertex. So therefore, position vector of fourth vertex of parallelogram is what? 7 I cap plus 7 J cap plus 7 k cap, and that is the question which we have, that is the value which we have to find out. Question is to find out what? Position vector of fourth vertex. In this way we have got position vector of fourth vertex. Now observe the next example, example number 15. In this example, the point P with this position vector, means this is the position vector of point P, which divide the line joining point A and B in the ratio 3:2. Means if you will observe the given condition, one segment is there, segment AB, and point P divide this segment AB in which ratio? 3:2. It is given to us. Now it is not given to us that this point divides internally or externally, but if you will observe the answers given on the last page, from that we can say that it divide this segment AB what? Internally. Getting it? So that's why we are applying section formula for internal division to find out required value, to find out what? Point B here. Means position vector of point P is also given, coordinate of point A is also given. Question is to find out coordinate of point B. So let us denote here position of this point by A bar, B bar and P bar. So let A bar, B bar and P bar be the position vectors of point A. What are the coordinate of point A? -1, 6, 5, B and P respectively. So what we are supposing here, A bar is the position vector of point A, B bar is position vector of point B, and this P bar is position vector of point P. So therefore P bar is equal to, already the position vector of point P is given to us, just simply we have denoted it by what? P bar. What is the value of P bar here? -14 I cap plus 39 j cap plus 28 k cap divided by 5. Okay, value of A bar will be equals to, from the coordinate of point A, value of A bar is equal to -I cap plus 6 j cap plus 5 k cap. Now using this we are trying to find out what? Coordinate of point B. So since point P divide this segment AB in the ratio 3:2, use this condition, means apply what? If ratio is given, means we are able to apply section formula. So since point P divides segment AB in the ratio, in which ratio? 3:2. So therefore by section formula, let us see what result we will get. Therefore by section formula, P bar will be equals to 3B bar plus 2A bar. 3B bar plus 2A bar upon 3 plus 2. So which is equal to 3B bar plus 2A bar. In the denominator what we are getting? 3 plus 2 is 5. 5 will get multiplied on this side. So on this side we will get 5P bar. Now our aim is to find out coordinate of point B. So we are collecting the term of B bar on one side and remaining term on another side. So plus 2A bar on this side will become minus 2A bar. So 3B bar is equals to 5P bar minus 2A bar. So which is equal to, now replace P bar by its value. What is the value of P bar here? Minus 14 I cap plus 39 J cap plus 28 K cap divided by 5 minus 2A bar. What is the value of A bar here? Minus I cap plus 6 J cap plus 5 K cap. So here 5 and 5 will get cancelled. Now we are collecting the terms of I cap here. So minus 14 plus minus into minus will become what? Plus 2. So minus 14 I cap plus 2 I cap will be minus 12 I cap. Now collect the terms of J cap here. So this is one term of J cap and this is the second term. Here coefficient is 39 and here minus 2 into 6 is minus 12. So 39 minus 12 will be equals to 27. 27 j cap. Lastly, collect the terms of k cap. Here 28 k cap and here minus 10. Minus 2 into 5 is minus 10. 28 minus 10 will be equals to 18 k cap. This is the value of what? 3 b bar. So to find out value of b bar, we are dividing both side by what? 3. So on this side 3 will get cancelled, and what we'll get if we are dividing, sorry, here we are getting 27. 39 minus 12 will be what? 27. So divide both side by what? 3. So here we'll get minus 4 I cap. Divide by 3, here we'll get 9 j cap. And if we are dividing here by 3, we will get 6 k cap. Simply this result we have got dividing both side by what? 3. Now b bar is what? Position vector of point B. So which implies that therefore coordinate of point B are. So what is x coordinate? Minus 4, y coordinate is 9 and z coordinate is 6. In this way we have got the coordinate of point B, and question is also to find out what? The point B means coordinate of point B. In this way we have got our required value here. Now in question number 16, question is to prove that the sum of three vectors determined by the median of a triangle directed from the vertices is 0. So let us consider here one triangle. So triangle A, B, C. Let us denote the midpoints by D, E and what? F. So ABC is one triangle, D, E, F are the midpoint of side AB, BC, AC and AB. So then segment joining this vertex and midpoint of opposite side is called as what? Median. So these are the three median, and question is to prove that what sum of the three vectors determined by the median. Which are the vectors determined by the median? First vector is AD bar, second vector is BE bar, means vector along what? Medians, and sum of these vectors along the medians, third vector is CF bar, and we have to prove that addition of these three vectors along the medians of a triangle through the vertex is equals to what? 0. And this result already we have proved in question number what? 10. So the solution of this example is given in question number 10. So try to go through question number 10 from the same question, question number 2, miscellaneous exercise 5. So we are now discussing question number 16. Just observe the question number 10. You will get the solution of this example.